two blanks say that you can write and graph inequalities to model real-world scenarios. The first chart that we see has some key words to help you with your word problems. Each of these boxes we're going to fill in with one of our symbols, greater than, less than, greater than or equal to, or less than or equal to. And that symbol would represent all of these phrases. So is more than, is greater than, is larger than, above. This one kind of gives it away. Greater than is just a greater than symbol. Now the next one, minimum, at least. This is the word that a lot of students get thrown off by. Is not, less than, not, smaller than. What symbol would I pick to represent those words? I choose less than or equal to, greater than, or greater than or equal to represent all of those words. Ashley? Greater than or equal to. Students for some reason see at least and they think less than. I don't know if it's because the L's sound alike, but you're saying at the very least I want so many dollars or so many kits. So anytime you see the word at least, you're always choosing greater than or equal to. Is smaller than, is less than, that gives it away, less than symbol. The last one, maximum, again, this word at most is one that students think greater than, but it should be less than or equal to. So for any of you that struggle with the word problems, you might want to study this chart a little bit just to help you with those keywords. So the first one says, suppose that your budget for a party allows you to spend no more than $120 on pop and pizza. What symbol would I choose for no more than? Abby? Less than or equal to. No more than $120. Pizza costs $2 per bottle, and pizza costs $10 each. Write and graph an inequality to model the scenario. Now, in terms of your X and Y, it does not matter which one you pick to be what. Okay? There's no independent or dependent. Like, pizza is not dependent on how much pop you buy, and pop is not dependent on how much pizza you buy. They're both kind of independent. So you can define them however you want. I usually just go in chronological order. So I'll say X equals the bottles of pop, and Y equals the number of pizzas. But you could have those backwards, and if you do, I'll check your graph on any of the open-ended questions, and then I would make sure that it matches up just kind of in the opposite direction of mine. Who thinks they could write an inequality, not an equation, to represent the scenario? And no more than $120. Garrett?
2x plus 10y is less than or equal to 120.
Perfect. Anytime you see per or each, that is representing multiplication. So that was why we had 2 times the number of bottles. 10 each would be 10 times the number of pizzas. We add this together, less than or equal to 120. All right, now, since we're doing a real-world graph, sometimes we do have to count by different units to be able to fit it on here. So for these ones, sometimes you will want to use your intercepts. So yesterday we always solved for y, which you can still do. You could subtract 2x and divide by 10. That's fine for a lot of them. But sometimes the numbers get significantly larger, and so we might have to count by tens or hundreds or something. So when you use your intercepts, that's when it can make it a little bit easier. So to find our x-intercept, we'll plug in 0 for y. And to find our y-intercept, we'll plug in 0 for x. And then we'll get our 2 intercepts, we'll plot them, and then we'll choose a solid or a dashed line and we'll shade appropriately. Okay, so we're plugging in 0 for y, we'll have 2x plus 10 times 0 less than or equal to 120. 10 times 0 is 0, divide both sides by 2. We'll get x is less than or equal to 60. And same thing with plugging 0 in for x. We'll divide both sides by 10, and we'll get y is less than or equal to 12. So those are the 2 values that I need to get to. So on the x-axis, I need to get out to at least 60. All right, so 10, 20, 30, 40, 50, 60. Let's count by tens. And let's also label that axes. X is the bottles of pop. on the y-axis, I need to get to 12, so what do you suggest I count my units by, Abby? 2. 2, 4, 6, 8, 10, 12, 14, 16. And this would be number of pizzas. And so, because this has an equal bar, this means that when I graph my intercepts, I am going to use closed circles. Technically, if this was just a less than sign, you would put open circles and a dashed line, okay? But since these are closed bar, we will do a closed circle at 60, a closed circle at 12. We're going to do a solid line too, and we are going to shade below. And I should say segment, because we're not actually going to put arrow tips on this one. Why? Why would I not put arrow tips? Yeah. Good. You can't have negative number of items, can't have negative bottles of pop or negative pizzas. So that's why we would just not put arrow tips. And then we are going to shade underneath that curve. Sometimes then they'll ask you for like 2 possible combinations of things you can afford. So that would be any ordered pair that falls in between. So one example of something you could afford would be 20 bottles of pop and 4 pizzas, or 10 bottles of pop and 8 pizzas. There's lots of possible combinations. You would want to pick whole numbers because you're not going to buy half a pizza or half a bottle of pop. Abby?
Is it like possible to have one open circle and one closed?
No, because they would all be coming out of the same equation. Now, whenever we get into systems of inequalities, you might have like another one that would have like an open circle, and shade below, but it will have both closed circles in the same question. All right, see if you guys can try example B, writing an inequality and graphing it using your interval. They wrote to model this scenario. Ashley? Perfect. It had said somewhere, at least, which is greater than or equal to. Again, if you were to have 15x plus 9y, that's also correct as long as you have your axes labeled in the opposite direction. Okay, number of pizza kits doesn't matter. And then we should be getting our intercepts then. Our y-intercept would be 135. Our x-intercept would be 225. Now, in the event that somehow when you're solving for your intercepts that you get different symbols, like one's a greater than, one's a less than, if you have to divide by a negative, you would want to go back and determine, solving for x, which way you're shading. Okay, so if you ever get different symbols at the end, I would always double check that. So on my x-axis, I need to get out to 225. I chose to count by 50s. 20s wouldn't work, 25 also wouldn't work. So I went with 50s, but you probably could have picked 30s too. So 225 would be right about here. And then on my y-axis, I needed to get to 135, so I counted by 20s. Oops. Sorry, so 135, 130, 135. Again, close circles because we do have the equal bar. Connect those, and did we shade above or below this final line? We shade above or below? Clayton? Above. And technically this goes off the page too. So even though we only counted up to, 160 and 350, we could go beyond that. All right. On the back then, we're going to take a look at some of our absolute value graphs. We will need to remember our vertex formula, and then we will just be adding in that inequality piece, so shading above or below the V. Caleb?
For example B, when you say below, what does that mean?
At least means greater than or equal to. At the very least, you want to make $2,025. At the very least, you really want to make more than that amount. So at least means greater than or equal to, not less than or equal to. If you look back at our chart up here, that's one that I told you just be careful about, because a lot of people do that one backwards. All right, so remember, our general form for the absolute value function was y equals a times the absolute value of mx plus b, close your absolute values, plus c. That was the general form that we saw. And who remembers the formula to find the vertex, which is our max or our min? Garrett?
Negative b over m plus c.
Good. Negative b over m, then it's just actually comma c, because it's an ordered pair. But yes, our positive c value, or whatever the c value is. So some of you on your last quiz forgot the negative, or just never bothered to memorize this. I'd make sure you have it memorized for Friday's test. All right, so graph each absolute value inequality. So you can use, if there's not really an A or an M or both, you can use some of your shift ideas, but I would always find your vertex just to be sure, okay? And then sometimes you will be able to use, like this is going to go 2 units to the left and 3 units down, some of your translations as well to help change. But you have to be careful if there's an A or an M or both, okay? Why? Because the M value will directly affect where your vertex goes. Okay, so you just want to be careful. It can change where the vertex goes instead of just shifting it. All right, so let's first find the vertex for this one. First of all, we should notice that this is really 2x plus 0. And if you don't need to add that in, you don't have to. But otherwise, you might not realize what your b value is. So this is my m, this is my b, and this is my c. So I'll use my formula for vertex, which would be my negative b divided by m comma c, which is negative 0 divided by 2, comma negative 3. And negative 0 doesn't exist, so 0 divided by 2 is still 0. Okay, so that means my vertex is at 0, negative 3. Okay. Now, if you want to, you could still do your table of values. Okay. Pick a number smaller than it and a number bigger than it and plug it in by hand. You could also use your graphing calculator if you wanted to calculate the values. But you also can use the fact that this is acting like our slope. Okay, this is acting like an up 2 over 1 situation. But what you have to be careful of is, let's suppose there's a 2 here and a 3 here. Okay, if you get a vertical stretch and a change in your slope, it's not going to be just counting up and over. So just be careful. You can always do the table of values and be sure, just plugging these back in. So negative 2, the absolute value of negative 2 is 2. 2 minus 3 is negative 1. Okay, but if you wanted to, we could have just counted up 2 over 1, up 2 over 1. And then remember, the absolute value will also go the opposite direction to make it into a V, so up 2 backwards 1 and up 2 backwards 1. And if, again, you do the table of values, you'll see you're going to end up getting those two. Now, before you connect those, we do have an inequality. So first, check out, we are going to have a solid line. Sometimes we'll have a dashed line. And this one is greater than, so we will shade above. So we're going to take and connect these the best we can. And above means inside the V. Okay. Above this line and above this line sometimes helps people too, if you think about it. You can still pick a test point if you want to. So 0, 0 would be a great test point to pick. And we would plug it into the original. So 0 is greater than or equal to the absolute value of 2 times 0 minus 3. So 0 is greater than negative 3. Yes, it is. Okay. The next one, again, I would find my vertex, even though you could use your translations here. So this is my M, my B, and my C. So I'll use the opposite of B divided by M. So negative 2 divided by 1, comma negative 3. So my vertex is negative 2, negative 3. And if you use your translations, you can see this would be 2 to the left and 3 down. So you can tell that works out too with our little memorizing. Now your A value is 1 and your N value is 1, which means this is just an up 1 over 1. So I wouldn't waste my time doing tables of values. And also an up 1 backwards 1. Now this one, we are using a dashed line. And we will shade above as well. So whenever you do this, if you want, you could just add in little in between each point. And we will shade above that curve. Okay, while we're here, grab your graphing calculators real quick. You can actually do inequality graphs in your calculator too, so I'd like to show you guys that. A lot of you may have never seen this before. So. And in case I didn't mention this, I don't remember if I told 12th period or you or both. Your chapter test on Friday is all multiple choice. So it will be 35 multiple choice questions, 2 points apiece, so 70 points total. So with a multiple choice question, there may be a question like this, and there'll be 4 graphs. Okay? So you could use the graphing calculator to graph it and then just look and see which one looks like that if you wanted to. Okay? So if you know how to use this, it can be a big help. So if you want to graph an inequality, just like we graphed an equation, we'll press the y equals button. This is all of your graphing tools. Now I have 2 things typed in. I need to clear out both of them, so clear them out. All right, now you'll type in this part into your y equals. So who remembers how to get the absolute value feature on my graphing calculator? What button do I have to press to get the absolute value bars? Caleb? Math, arrow over to number, and the first one, ABS. Inside I'll type x plus 2. I'll close my parentheses. Anyone with a new calculator, just hit the arrow over button to get out of your absolute value bars, and then we'll put a minus 3. Not a negative 3, but a minus 3. Now, if you graph it right now, it's going to give you just the line. If you want to do an inequality, if you go back to this, see these little lines that are over here? So if you arrow all the way back, and you could have done this first, I guess, until it's like kind of blinking over there. If you hit enter 1 time, it'll shade to be like a bolder line. If you hit enter again, you'll see that it's shaded like above a line. Do you see how it's like the above region? That would be indicating the greater than symbol. Okay, so hit zoom 6. Remember, zoom 6 is your standard window. And ta-da. Invalid. Okay, so go back to your y equals. Did you put a negative? Anyone else having that problem? What's in the air? So everyone's able to see this. When you go back to your y equals and you clear that out, it will reset it back to a line. Okay, but if you were to want to do something that's a less than, you would just hit enter, I think, 4 times then. And you would see like the shade underneath, and then it would shade underneath your graph. Okay. All right. Now the next one, the next 2, you'll notice they are not in our standard form. So for both of these, the first thing we're going to have to do is solve for y first. Okay. So what would I need to do to solve this one for y? Jade?
Subtract 3.
Good. Subtract 3. Now, be careful. You're not allowed to subtract 3 in the absolute value. So the minus 3 over here is just going to go tacked on at the end. So we have 2y is less than or equal to negative absolute value of x minus 5 minus 3. And then we need to divide by 2, right? Which normally is really easy. This is going to be a little bit different. Now, you are dividing this whole side by 2. Technically, what you're going to do is you're just going to divide the outside numbers by 2, not the inside absolute values. So in front of the absolute value, there's actually a -1 in front. So we're going to make this -1/2 times the absolute value. This part does not get divided by 5. And excuse me, by 2, because we're going to do what's inside of there. Then when you multiply by 1/2, you'll be dividing those values by 2 later. Okay, but you also need to make sure that you keep this one, the outside number, divided by 2, which would be -3/2. All right, now let's find our vertex. -b divided by m, comma c. So this is my, remember, this is not your m value. This is your a value out front. That's your stretch or your shrink. The m value is technically a 1. The b is a -5, and the c is a -3/2. So we'll take the opposite of b, which would be a +5, over 1, comma, -3/2, or -1.5. So we'll plot that. Down 1.5. Now, since this one is a little more complex, maybe you do want to do a table of values and do 4 and 3 and 6 and 7. Okay, if you don't want to, you don't have to. You can use your rules for translation. So what's the negative, tell me, is going to happen with this graph? What's the negative in front, tell me? Abby? Good, it's a reflection downward across the x-axis. Okay. And the 1/2 is a vertical shrink. Which again, shrinks act like a slope as long as there's not an a and an m value. So if you don't want to do the table of values, plugging everything in, you would just from here need to do a shrink of 1/2. So I would count, since I'm going a reflection, I'll go down 1, so I'd count down to the next half space, and then over 2. And I would also count down 1 and backwards 2. Down 1. Again, if you don't trust that, by all means, plug in your values and complete your table of values. Or you could also type this. You have to type this into your app graphing calculator if you want. It has to be in the y equals format. Oops, before I connect those. I do have a solid line. Okay, so that's fine. And this one we're shading less than. So that is underneath the absolute value. And it would benefit you to probably pick a test point, just to make sure you didn't screw this one up since there's so much going on. So again, 0, 0 doesn't work, but you could pick maybe 0, -1, 2, 3, 4, 5. And I would plug that into the original one, just to be sure. So we'd have 2 times -5 plus 3 is less than or equal to negative absolute value of 0 minus 5. And so we would get -10 plus 3, which would be -7, is less than or equal to -5. And -7 is less than -5. So that would check. Okay. D, I again need to solve for y. What would I need to do to both sides to solve for y? Caleb? Subtract 2. Good. Make sure you subtract 2 outside the absolute value. Some people make the mistake of like changing this to a 1. So don't do that. We'll have negative y is less than or equal to the absolute value of x plus 3 minus 2. And then we need to divide by -1. Now remember, when we divide by -1, we are going to flip this inequality sign. So this will become y is greater than or equal to Now, remember, there's a 1 in front, so the only things that get divided by -1 are the outside numbers, not the inside numbers. So 1 divided by -1 is -1. So that stays x plus 3. -2 divided by -1 would be a +2. Abby, I saw your hand up.
There's no equal sign.
Oh, thank you. I added in an equal bar. My own record. Thank you. So again, do not change the symbols that are inside the absolute values. Those are staying exactly as is. The only thing that's getting divided are the actual outside numbers. Okay. And again, let's find our vertex, just to be sure. Although this one, you could use shifts left and up, left 3 up 2. But let's just double check. M, B, C. So this would be -b divided by m, comma c. Which is -3, +2. Now again, since we have this negative out front, Abby told us last time that that means that the graph is going to be reflected downward, which is our reflection. And if you notice, the stretch is a 1, the slope is a 1, so you can just do your 1 up 1 over 1. In this case, it'll be down 1 over 1, because the v has to face downward. And I'm glad Abby corrected me, because now I will have a correct dashed line here. And we did flip it. Make sure you look at that final symbol, which is a greater than. All right, who can tell me what they got for 3A? We should have y and Ashley? Very good. This was a linear function, less than or equal to, solid shape below.
Anyone who has signed up or is interested
Y-intercept is 3, down 1 over 2, down 1 over 2.
Should report to the guidance department at this time. Thank you.
This was the hardest one. Who thinks they got it? Garrett?
Y is less than or equal to the absolute value of x plus 4 minus 3.
Perfect. Okay, first of all, pick your symbol. Solid line, shade below, less than or equal to. The vertex has been shifted 1, 2, 3, 4 units to the left, which is to add 4 inside, and it's been shifted down 3. And then always check, is it going up 1 over 1? Yes, so I don't have to put a number in front. Okay? And the last one, C. Someone I haven't heard from today. Oh, thank you. It's there. John, you're the closest. What did you get for C?
Y is greater than or equal to 2x plus 5.
Perfect. Perfect. All right, you guys have the homework done?